Trufan, and in today's experiment, we're going to explore chromatography. For this experiment, we're going to need some chemicals. First, we'll be using a 70% isopropyl alcohol mixture. We will need some deionized water. We'll need some sodium chloride or table salt. We will use food coloring for different colors of it. And then this is optional. You can choose whatever food source that contains food coloring of your choice. Here I have a packet of purple Kool-Aid and a bag of assorted M&Ms. For our equipment, we're going to need some large filter paper. And for today's experiment, I will need 2. I will need 3 large 400 milliliter beakers. You can use just 1 and alternate, or you can use 3 and do the experiments at the same time. Here I have all of these marked. In one of them, we will put the 70% isopropyl alcohol solution. In another one, we will put deionized water. And in the third one, we will put a mixture of salt and deionized water. We're going to cut our filter paper into rectangles first. So we will be using a ruler to make sure that our edges are straight. To cut them, we need a pair of scissors. To mark them, we're going to need a pencil, and then we're going to use some assortment of pens and pencils to hang those pieces of filter paper inside our chambers, which today will be our 400 milliliter beakers with the solutions in them. To add the appropriate amount of salt, we're going to need a scale and a weighing boat. And then for today's experiment, I will be using a weighing boat to add drops of food coloring so I can extract a small amount of each one. To add the same amount of solution to all of my beakers, I will be using a 50 milliliter graduated cylinder. To suspend my filter paper, I will be using some Scotch tape. To add the food coloring, I will be using an assortment of toothpicks. And to cover my chambers, I will be using some plastic wrap. So first, we're going to outline the shape of a square on this circular shaped filter paper. And we do this on both of them. With our shapes marked, we're going to cut them out. We can discard of the remnants. And then we take one of our pieces of paper and we find the straightest edge of the 4. We place that edge facing us and we take our ruler, and somewhere about ½ centimeter above the bottom edge, we're going to draw a line with a pencil. It is important that we do this with a pencil because otherwise our pen may be water soluble and that ink may smear and interfere with our separation. We do this on both pieces of paper. Now with our bottom lines marked, we're going to take both of these papers and we're going to cut them in 3 very similarly sized strips. With that, we're done with our strip preparation and we can set our ruler and our scissors to the side. Next, we're going to prepare our solutions. First, we're going to have our salt and water solution. We will take our scale, turn it on, get a weighing boat, place it on top, tare it, and then we're going to add 0.5 grams of salt. I measured 0.51 grams of salt, and I will put this into my first beaker. With that, I am done with my scale for the experiment, and I can set it aside. Next, we need to dissolve our salt in water. So we are going to take our 50 milliliter graduated cylinder and our deionized water and measure 25 milliliters of water. I have 24.9 milliliters, so very close. I will pour this into my beaker that has the salt in it. Next, I'm going to swirl my solution until all the salt dissolves. And It is already done. Next, I am going to measure 25 milliliters of deionized water and pour it into my second beaker. It is a little bit more. It is 25.6 milliliters. And for my third beaker, I am going to add my 70% isopropyl alcohol, again, 25 milliliters into the graduated cylinder. It is just a little under at 24.8 milliliters. I will transfer this into my final beaker. And now my solutions and my water are ready. I can set both my deionized water and the alcohol to the side. We can remove the graduated cylinder because we're done with it. And for the next step, we're going to use our food coloring and prepare our strips for the separation. We're going to take all 3 strips from the same batch. We're going to place them in front of us. Take a weighing boat, but it can be a different container that is relatively small. We're going to use our food coloring and place 1 drop of each color in the corners of our weighing boat. And with that, we can set our food coloring to the side and bring in our toothpick. Now, 1 toothpick at a time, we're going to dip it into the first color and then draw the faintest line or mark the smallest drop on our piece of paper. I will begin with the red. And when I am done, I will set my toothpick to the side. Next, I am going to move on to the second color, which is green. Next comes blue. And then we switch to our final color, which is yellow. And when all 3 are marked, I am done with the food coloring. Next, I will switch to submerging the pieces of paper in such a way that the top of my solution layer will be just under the line where my colors are marked. I will take 1 of my beakers, a piece of Scotch tape, and then on the front of the beaker, I will mark how far in my strip of paper will have to go. Add the pen, in this case, to it, and then take my Scotch tape and tape the piece of paper to my pen. And with that, I will submerge my piece of paper in the solution. There's always a possibility to adjust slightly. And now I am going to cover this up with some plastic wrap and leave it until the water goes up all the way to the top. With that, I am ready to move on to my next solution, which is the 70% isopropyl alcohol. For that, I'm going to use my pencil, mark the level of the paper, get a piece of Scotch tape, and tape the pen to the paper. And I will cover this up and let it move up. And with that, I can set this beaker to the side as well. And at the end, I'm going to do the same thing with my deionized water. And with that, we add some plastic wrap on top. And we wait for the colors to move to the top. While our colors from the food coloring are separating into 3 different solutions, let's move on and set up for our determination of what food coloring is present in the coating of M&Ms or in the mixture for Kool-Aid. We're going to take our other 3 strips of paper, and we're going to have a couple clean toothpicks. We'll need a clean container in which we're going to put our candy. And we should aim for at least 2 or 3 different colors. Here I have a yellow, a green, an orange M&M. And for our 4th color, we're going to pick a brown. We're going to move all of our candy into separate corners of our weighing boat, bring in some deionized water, and then with a pipette, we're going to add a couple drops of water on top of each. And let's not move our containers so that when we add the water, all our colorant is going to move into the corners and not blend. And with that, we're done with the water. And we're going to wait a little bit for the water to dissolve as much of the food coloring as there was coating the candy. Once we are happy with our dissolution, we can take a toothpick, extract a small amount of dissolved food coloring from the same candy. And in this case, I am working with the brown coating. And draw a small line or create a small drop on the first piece of paper. Then we are going to do the same thing on the second piece of paper with the same color. And then we do the same thing for our 3rd filter paper. When we are satisfied with the color intensity on all 3 strips, we discard of the toothpick to make sure that we don't contaminate other samples. Then we take another toothpick, select our 2nd candy, and trace a couple lines on our filter paper. When we are done with the first one, we move on to the 2nd, and then to the 3rd. When we are satisfied with our color on all 3 strips of paper, we move on to the 3rd one, and then the 4th one. And now for the last one, the orange. Now we are done with our toothpicks and we are done with our candy, and we can set it aside. While we are waiting for the little markings that we added to our filter paper to dry, we are ready to look at what happened to our solutions. In this solution, we had sodium chloride and water, and we noticed that the water layer went up almost all the way to the top. So let's extract our paper. We can place it on our bench top, and it may be better to put it on a piece of paper. This is the time when it is important that we dry it completely. If we have a heat gun or a hair dryer, we can certainly use that to speed up the process. We can also alternately put it on a hot plate on very low heat, and that will help us. But with the hot plate, we have to be very careful not to scorch the paper. So this is what it looks like for me. The next step for me will be drying the piece of paper. My paper is dry now, and it is important that before we can do any analysis on our chromatogram, that we mark our solvent front. And that means we're going to take our ruler and we are going to draw a line at the spot where our saltwater solution was at its highest. And that was right after we extracted it from the beaker. Next, we're going to mark with the ruler just a small line at the top of every color. And then we will also mark the bottom of every color. And sometimes if it's just a small mark, we can do it without the ruler. But if it is a larger band, it is better to use the ruler. When all our markings are complete, in the meantime, we're going to watch our solvents in the other beaker, and we can see that the one with the water has moved up substantially and it is almost at the top. So we need to extract this and mark our solvent line. And we can do that with the pencil, and then we're going to move forward and dry this as well. We're going to do the same markings on our chromatogram that was done with the water. We're going to mark the solvent front. That will be a straight line. And then we're going to mark the top of all the colors and the bottom of all the colors. And we're going to estimate things here because sometimes the color may be a little faded or there may be some overlap between the bands. It appears that the slowest of these solvent mixtures to move up on the piece of paper is our isopropyl alcohol mixture, but everything that involved water is going pretty quickly. While we are waiting on that, we're going to record some measurements. And I am going to demonstrate this on my first chromatogram, the one that I used the saltwater solution for. I am going to take a couple measurements here, and I will record these. For the height of the solvent front, I am going to determine the distance between the marking where I had all my colors laid out on the same line, or my starting point, and where my solvent went up. So I am going to place a ruler next to the two markings, and I am going to record the distance. And for me, that is 8.67 centimeters. And then I am going to repeat the same measurements for the top and the bottom of each colored layer. If there is an overlap, I'm going to keep that in mind. In the case of the red food coloring, I can tell that there are two colors, but they are very mixed. So I am going to keep them together for the purposes of this chromatogram. But on chromatograms on which they separate, I will have those separated. For the height of my red food coloring, I have 2.91 centimeters. And the bottom is still at my starting point, so it will be 0.0 centimeters. And then I can move on to my green food coloring that clearly has two components. According to this chromatogram, there is a blue on the top and a yellow on the bottom. And for each one, I can measure the furthest from the starting point line and the closest to the starting point line. So for the blue, I have 6.59 centimeters for the top and 3.51 centimeters for the bottom, or the tail end of the blue food coloring. For the yellow, I have 2.99 centimeters for the top and 1.52 centimeters for the bottom. I will repeat the same measurements for all the other colors as they appear separated on my chromatogram. If they are not separated, I will take the combination of the colors as they appear because the separation has not been achieved from that solution mixture. I will do the same thing for my water chromatogram as well. Next, we're going to wait a little bit longer for our isopropyl alcohol to move very close to the top. It is about 2/3 of the way there. And once it gets closer to the top, we will extract it, dry it, and perform the same measurements on it before we are ready to move on to our candy colors.